So we begin your 123 journey talking about something that you've heard of before. When we talked about acids and bases, this representation here is pretty common for what you've seen for acids. And this here for bases. And so what we said is that this is, you've probably heard it as either a proton or, let me make that neater, or a hydrogen ion, and this is always just a hydroxide ion. And so Arrhenius simply defines an acid as anything that increases the concentration of our hydronium ion, and a base is anything that of our hydrogen ion, of anything that increases the concentration of our hydroxide ion. Cool. And remember, the brackets just mean concentration of. I'm going to start doing that just so you get more comfortable seeing it with regularity. So what I want to point out to you here, though, is, oops, let's not do that. There we go. Is that this H plus actually comes from this kind of reaction. That we take a strong acid, and we'll have another video talking about that, and we're going to put it with water. And then remember, we said a strong acid is defined as something that will completely dissociate in water. So that means that this hydrogen, this proton, is going to pop off and go to this electron-rich oxygen, and we end up with something like this, with H3O+. So this guy is our hydronium ion. So we want to start getting in the habit of using this representation rather than just the H+. There's certain times that this is okay. When we're doing work down the line with pKa's and all that, then this is fine. Then using the hydrogen ion is fine. But when we're balancing our equations, we're going to start doing it with the H3O ion instead of the hydronium ion instead of the H+. Okay, so let's do just a quick one. Let's do HCl because I've already started there, and sodium hydroxide because that's something you see a lot of. And that is going to go to our water, so we've neutralized it, and a salt, NaCl. Now, if you don't remember how to do these kinds of reactions, I am going to do another one on spectator ions and net ionic equations. But just remember, we have our acid here, so here's our +1 and our -1. And if you look at your periodic table, you know that this is also +1 and this is -1. So it's just a swapping of partners that's going on here. This is going to come over here, and then this guy is going to come over here. Cool. So then we end up with our salt and our water, and we are neutral. And this is an Arrhenius acid and base.